Okay, so let's just practice this if condition a little bit more. In this particular video, we are going to achieve a particular task. So let's design some task here. By the way, this is comment. Comment is, it starts from a hash symbol, and that's a statement that will never be executed. This just describe your code, for example. So it is not there, but it is there as a text, but not as a code file. Like hash sometimes represents comment or description with a single line. If your comment goes on multiple lines, it is good to write a multi-line comment. So that's a single line comment, for example, single line comment. The multi-line comments, they start with 3 quotes and then end with 3 quotes. So whatever you write inside in these in this particular block, that's a multi-line comment. So let's describe our problem in this multi-line comments, because that's the problem in form of text, and then we will be solving that problem using the code. So that's just description of the problem. Let's say user will enter a floating point number, let's say 238.915, let's say. Okay, your task is to, so let's just more readable. Your task is to find out the integer portion before the decimal, before the point, let's say before the point. In this case it is 238, and then check whether if that integer portion is an even number or not. So just print yes or no. So print even if it is even number, otherwise print odd. So that's the problem statement. That's the problem that we are going to solve. And this is just comment. Now we are outside the comment. That's a multi-line comment. Yeah. So how to solve that problem? How to solve that problem? So let's start solving this problem. I'm going to spend some time on this program just to get comfortable with the if conditions. Let's say that number is x is input. Let me convert that input, enter a real number, let's say. Okay, we are just assuming that the user will enter a real number. It's a real number. Real number might be, 238.0, that's a real number, or 238 itself, that's also a real number. That's okay. But we're not assuming that the user will enter, let's say, some characters like ABC or stuff like so. Just assuming that. Okay. Now, assume that x contains a real number. It may be an integer by default. Maybe user just enters 10, and that's it. So it may be already an integer. Then we have to check whether that 10 is even or not. Or the user may enter 11.7, or the user may enter minus 34.7, or the user may enter just 0, or user may enter just 0.35. There are a lot of possibilities that the user come up with. This x can contain any kind of number, and we have to check according to. So how can we move? Let us just see whether that number, let us just extract the decimal portion, the portion before point. Let us just extract that. How can we extract that? There are two conditions. First of all, let's see, if x is positive, then do what? Else do what? So let's write this structure first. If x is positive, then what we have to do, and if x is negative, then what we have to do. So if x is positive, then what we do, we just so what should we do? I'm just stuck here. How can we extract the decimal portion, the portion without this particular thing? How can we extract that? That's tricky. That's kind of tricky. Yeah. So any ideas? I guess this the structure I'm using. Let us just first think that x is positive. Just make our life easier, and then if x is positive, it's a positive number. How can we extract this portion out? Just the number that is below, that is before the decimal point. What should we do? Can we apply a round function? Will that help? X, will that help? Helps? Yes or no? Round function. So let's say y contains the rounded value of x. Then so what? Then how can we extract the decimal portion, the integer portion? Or maybe there is a function that actually round downs. Let me check whether there is a function float or not. No, float is not a function, I guess. So let's say round x. Okay, now y contains the rounded value of whatever the x is. We are now assuming that x is positive. Okay, then what? Now if y is larger than x, that means we moved up. Okay, we moved up, the round goes up. In that case, what we do is we just subtract so we just subtract the integer portion. So the integer portion, let's say that's our variable name. Then the integer portion is simply y minus 1. Is that correct? Is that correct? If y is larger than x, then integer portion is simply y minus 1. For example, just think about it. If when for example, if the value was 29.6 and the rounded value will become 30, so 30 minus 1 will be 29. That is what we are interested in. So yeah. So otherwise, if for example else if y is not larger than x, then y itself is an integer portion. Y itself is an integer portion. Is that correct? I mean, is that making sense to you? That if, for example, if x is larger than, if the rounded value of x is larger than x itself, then we just subtract 1 and we get the portion. Otherwise, the rounded value itself is the portion. Let's just run this code for now and check whether whatever we have done so far is correct or not. So after that, just print, let's say, the integer portion. Let's just print that. Okay, so enter a number. Let's say the number is let's say 25.367, let's say. Obviously the integer portion here is 25. So let's see our program returns 25 or not. Oh, the result is 25 magically. Oh my god, we found 25. Let's run it again. Just to see. Okay, let's run this again, and this time let's give it to 45.8. okay, the integer portion is 45, but when we will round we will get 46, and 46 minus 1, we will dive into this particular if condition. Let's see. Oh, the result is 45. We are still moving very well. Great, that's great. So okay, let's play with it. Let's give 0.2. The result should be 0. It is 0, right? Let's run it again and give it, let's say 4. That's it. The result should be 4 now. It is 4. Great. So we are working very well. We have extracted the integer portion as long as the number was positive. Okay, great. What if the number will be negative? Let's say that was true. If that was true, so that whole logic works if x was positive. So if x is positive, then whole this logic just works. Okay, then else what should we do? If x is positive, then this logic works. If x is not positive, then what will happen? Then how can we find out the integer portion? Because first we have to find out the integer portion, and then we have to find out whether that integer portion is even or not. Finding out whether that integer portion is even or not might be simpler, but first we have to find out the integer portion. So for example, let's check the behavior of round function on negative numbers. Let's say round minus 9.3. So the result is minus 9. Okay, if we say okay, round minus 9.6, the result will be minus 10. So it looks like the same as working in the positive numbers. So round function is actually working roughly the same way it should work in the positive numbers. Okay, so what should we do here? Any idea? Maybe we first convert by the way, yeah, maybe we first convert the number, let's say y equals round x again like before, but then what? So maybe this rounding helps the same way. Maybe the rounding helps the same way. We should extract this x out from this here, because it is going to work in the else part as well. Why to compute it? Why to write this redundant code? So y is round x, let's say. Then if y is greater than x, what should we do? If it is negative, y is greater than, then what will be the portion? It will be, the integer portion will be what? Y minus 1 or what? Y plus 1. Yes, you got the answer. That's y plus 1. Great. And else, I guess we have integer portion equals y itself, I guess. Yes, I guess that's the code. That's the code, I guess. Let's check, by the way, but I guess that's the code. By the way, this else part is same in both of these conditions. So maybe we can combine this code and write a more elegant code, but I guess this will work. Let us just print the integer portion just to check whether we are working well so far or not. So let's enter, let's say 12.3. The result is 12. Great. So it did not change our previous, I guess, our previous logic. So let's say there is minus 9.8. Now the integer portion should be minus 9. Oh, it is returning 10. Why is that? Oh my god, this should be changed. When it is round, it may go that way, or when it rounds, it actually becomes lesser than 10, because when it rounds, it goes up and it becomes lesser than. In negative world, this condition should flip. Yeah, so we are making an error here. Let's fix that. Okay, let's run this again and see. Let's say minus 93.2, minus 93. Great. So then we have, let's say, let's run it again, minus 8.9, minus 8. I guess we are working perfectly fine. Once we have integer portion with us, we just write here at the very end, if integer portion remainder with 2, if that equals to 0, print even, otherwise else print odd. That's it. That's the whole program. Let's see, and let's see how is it running. Let's say 22.6, it's even. Let's say minus 87.3, that's odd. Great. So you see the power of if condition and how can we think in writing these programs and stuff like so. That was a lengthier video, I know, but I guess you get a very good look and feel of if conditions and thinking and building a logic and all that stuff. So in the next video we will start loops. So that's a beautiful structure. Hope to see you in the next video.